Alright, welcome back guys. So if you guys remember, last time we were at this point in which our code was erroring out, and the reason was it was actually a timeout error. And in the backend, if you guys know, our endpoint was getting deployed. It takes roughly around like 1.5 hour, maybe 2 hours sometimes, to deploy. So that's just the way in which this thing has been set up. So one of the things that you can do is you can add this parameter, although I don't see this thing working either, but you can just wait until this thing gets deployed and then you can go ahead and perform the task. So you could see, although this thing has error out here, but what's going to happen is the connection is still going to work because this thing's deployed in the backend. It just took a little longer time. So one of the things that we're going to do now to check connection and rest of the things is we're going to perform a similarity search. So basically we'll be giving a question or like a query, and we would be giving that to Vertex search AI vector search, and then basically we're going to find the neighbors near to it. One of the things that I actually forgot to mention in previous tutorials was that one of the way in which the whole system is set up, the way in which basically these embeddings are stored inside this vector search is by using this thing. This is the distance type dot product distance, and I've actually included this thing as one of the resources that you guys can see. These are the different types of distances that this thing provides. Cosine similarity, this is something that's used the most, and it has a lots of I believe it's used at a lot of places, so lots of use cases, but in our case we just took whatever was the default value and we went ahead with it. So that's also fine, but it's just that for a better result you can use cosine as well. With this thing, let's start this similarity search in which we're going to find nearest neighbors to our query based on the dot product system that we set up. So one of the first thing we're going to do is we'll be writing a function that would convert a text into an embedding. This is the same code that we have used in our previous tutorial. There's nothing different about it. We are going to use the same model obviously as well. The next part is we're going to write a query and we're going to convert that query into an embedding. Again, really simple thing, the same thing that we have done before. And the next part we're going to do is we're going to make a request to our endpoint to the same deployed index, which was like this one that we deployed. We're going to do that, and you can specify this number as much as you want. I've just set 3 because let's say if I want to get 3 closest closest things to it, closest neighbors to the given query. So what in response here, if I go and run, and we're going to get a response, and let me just explore the response, and as you can see, it's gonna be like this whole list that you're going to get. Basically it would say that this is the ID of the index that is matching, this is the distance, and like some other things. This is again another neighbor, and likewise you might have the third neighbor that you would see here as well. So these were the 3 neighbors, right? So this is how we got. Now obviously what we got here is the index of those neighbors. We don't have the embeddings, we don't have the text. So what we are going to do next in this case is we're going to convert those indexes into embedding. So this is easily how you can do it. You just have to run this function. Again, it's an inbuilt function, so you guys can run it, and basically you would see a whole embedding here. And then what we're going to do next is we're going to convert this thing into the actual text. And if you guys remember, we had if you guys remember, we had this in JSON format and ID, and from that JSON we can go ahead and we can basically convert that into our into like our text. If you guys remember, we had a JSON that we developed here. So based on the index, we had a text. So basically we're just going to get that index, and we're just going to get the text that's corresponding to that ID. So let me just go ahead and run, and as you guys can see, these are the 3 these are going to be the 3 common most common obviously neighbors to the given query. This is really simple, guys. All you need to do is just just perform a similarity search. Although you could see there was an error here, but it was completely fine. In the back end it was still deploying, and Basically, we just perform a similarity search by just having a query. We converted that query into an embedding. We send that embedding into our index endpoint to find nearest neighbors, and then we got 3 nearest neighbors based on the condition we gave. Then from there we went ahead and converted those neighbors into embeddings based on the index that we gave, and from there we also converted them into text as well. So this is really easy. You don't need to do much. So this is everything about this. Now in the next tutorial, we are going to use actual the last part of the RAG system. Basically, we're going to use Gemini, in which we would be using the results of this neighbors, like all these 3 neighbors, and we're going to use our original query, which was this one. And what we're going to do is we would give this to Gemini, and we would tell Gemini to actually give us answer of this thing based on these neighbors that we found. So that's something we're going to do in the next tutorial. See you guys there. Thanks so much.